Christopher Nolan's The Odyssey is in theaters now. That's an adaptation of Homer's epic poem, but a real life Odyssey is set to begin next month. It's a remarkable scientific experiment. A team of scientists will travel to Kirkenes, Norway. That's a small, remote Arctic town. There, they will climb aboard a floating laboratory. That's the Tara Polaris I. What follows will be an 8-month expedition on the impact of climate change and pollution on the Arctic Ocean. For more, we can speak to Marcel Babin, the scientific director of the Tara Polaris I expedition. Marcel, thank you for speaking to Paris Direct. For many people, 8 months trapped in ice sounds like a nightmare. For you and your team, it's the opportunity of a lifetime.
Yeah, well, we are very well prepared, but it's indeed quite an extreme experience in a life. It will require, so we will get in the Arctic, get trapped in ice with our new ship, which looks like a little bit like an UFO. It has been designed to resist to the pressure of sea ice. We will go there, get trapped in sea ice, and then go through the polar nights, the winter in the Arctic with -40, not much light, presence of polar bears. And during that time, using our laboratories, we will monitor what happens in the atmosphere, in the sea ice, in the ocean. We will put much focus on life in sea ice and in the ocean, and how it is adapted to go through the polar winter, and how it may respond to current changes that are ongoing in the Arctic.
Yeah, you say you're well prepared. Just real quickly, how do you prepare for something like this?
Well, we started thinking about the science program 8 years ago. We assembled an international consortium of scientists with various experts of the Arctic, as well as ocean biology experts. And we figured out what we could do that could be useful and could bring useful new knowledge. And together we've identified a number of priorities. Then with the labs that were involved, we started preparing what we would measure, the equipment we would need, all the consumables we would need. Then we have decided about who will participate exactly. And it was a little bit like the International Space Station, where you have a small number of people, 12 people, who will do a number of sample collection for a group of 34 labs on land. So they will be very busy, and this is what we all prepared. You know, we selected people, make sure that they were physically fit, that they were psychologically compatible with that kind of adventure, and we trained them as well for doing all the work we need them to do to collect the samples during these 8 months. And of course, so it's a small platform. You have to prepare everything, the food for this long period, all the consumable. You have to manage the wastes, the chemicals, and everything. So it was very demanding and a little similar to planning a space mission to some extent.
Yeah, that's what it sounds like to someone, at least a layperson like myself, Marcel. The Arctic is warming 3 to 4 times faster than anywhere else on the planet. For any of our viewers who might be asking questions, why is the Arctic so important to the rest of life on Earth?
Well, first, it's one important ecosystem on Earth. You know, about 10% of the ocean is covered by sea ice at least during 1 month a year. So it's an ecosystem that's important. The Arctic Ocean is very much affected by climate change. So temperature is increasing 3 to 4 times faster. Sea ice is disappearing. So it's really it's very much disturbed. Everything is disturbed. The way the atmosphere, the sea ice, the ocean work, how life can develop also in this environment, which is changing very quickly. And the Arctic, although it's remote, is very well connected with our latitudes, and especially in Europe, through ocean currents, but also atmospheric currents. And what happens there, and in this place, which is a kind of reflector for our planet, a cooler for our planet, what happens there does have an impact on what happens at our latitude. And if we want to determine the trajectory for our planet in the coming decades, we need to collect more data to figure out how this system works and to develop better models that allow us to make those predictions.
Marcel, we're going to show the images of the Tara Polaris station, at least this 3D model of it on air right now. I'm wondering if you could explain to us how it works and exactly what the team on board will be doing.
Okay, so so there's about it's about 500 square meters of surface at different levels, and which includes about 150 square meters of lab space. From where we will first collect samples inside the ocean through a well that has been built in the middle of the ship that will give us access to the ocean all the time, despite the fact that we will be surrounded by sea ice. And we will deploy a number of sensors, but collect water samples down to 2,000 meters deep. And we will process those samples to be analyzed on land, or we will directly make measurements. So this is one part of the science program. The other part of the science program will take place outside, either from the decks, from the roof, or from the decks, where we will deploy a number of other devices that are meant to explore the atmosphere, to sense the atmosphere, especially to collect aerosols and to also look at clouds. And finally, on sea ice will be used as a working platform as well. We will deploy many different systems on sea ice. So either moorings, a number of sensors looking inside the ocean to measure currents, for instance, to look at fishes using acoustic systems, or we will also deploy a tethered balloon attached to a winch with a 2,000 meter long cable that will allow us to profile the atmosphere, to go up in the atmosphere, and along the trajectory of this balloon, using sensors on board the balloon, we will make measurements, and we will collect aerosols also that we are interested in, because we think that these special aerosols, which also contain bacteria and other living small organisms, we think that they will affect clouds in the future. And clouds are important in the Arctic at a time when sea ice is changing. Clouds may be more frequent. So the balance between the two in terms of reflection of sunlight or in terms of isolation of the planet, is undetermined. And this is the kind of thing we will address.
Yeah, and Marcel, real quickly, the risk to the scientists and the crew themselves. I mean, in case of an emergency, you can be reached, but you're so remote that it would take possibly a week for someone to get there. So tell us a little bit about how you respond to that, the danger of this isolation.
Yeah. So first, so everyone is very well trained. We will limit the risk. We have a doctor on board. We are pretty well equipped, in case we have an X-ray machine, portable X-ray machine, in case of fractures. But otherwise, indeed, there are risks. It's a harsh environment, especially during the polar night. Sea ice is not kind of a flat surface. It comes with a lot of ridges, kind of ice mountains all around. During the polar night, the visibility is very much reduced. Sometimes there's fog. There are polar bears around. It's very cold. It can reach temperatures down to minus 40, if not minus 50. So yes, there are many risks, and we are trying to mitigate those risks, to take into account the fact that we are far from everything, and an evacuation would require days to weeks. So we can't, in a sense, afford for accidents during that mission. So it's not the people that who will be on board are not adventurers, although they do like adventure, of course, but they are well aware that we are there for to be professional, have a professional behavior, and always manage the best way possible the risks.
Marcel, thank you so much. Good luck with this mission. I'll be sure to follow along and see how you and your team are doing. Marcel Babin from the Tara Polaris I expedition. Thank you.